This slideshow explains some of the work that took place at the Sellwood Bridge in Portland, Oregon during July and early August of 2012. The main parts of the project during this time were the installation of ground stabilization structures near both ends of the bridge, the addition of A-frames on top of the river piers, and building demolition on the east side. All efforts are currently focused on preparing to construct a temporary bridge for use during the construction of the new Sellwood Bridge. This was Pier 20 in late July. Here's the same pier in mid-August. Let's see what happened at Piers 18 and 20 for what was done during the intervening weeks. After driving the remaining piles to their required depth, many piles had to be trimmed off so that all the piles had the same elevation at the top. Here, a worker makes a hole in the top of a pile so that the crane can put a hook through it to remove the segment that gets trimmed off. Here, workers use a device to trim the pile so that the top edge of it will be level. Once the cut is complete, the crane removes the trimmed off section. A survey instrument is used to verify the elevation of the trimmed pile. These caps are then bolted to the top of each pile. A barge is positioned near Pier 18 with a load of gravel. A large bucket, suspended from the crane, is filled with gravel from the barge. The crane positions the bucket near a pile, and a worker directs the gravel into the narrow gap between the pile and the supporting frame in which it is encased. In July, a barge delivered these A-frame structures and short steel beams to the site. The beams are used to create footings on top of the caps shown a moment ago. Then the A-frame is placed on top of the footings. This is Pier 18. Returning to Pier 20, a work platform has been built on top of the A-frame. Pier 20 also has an extra two-legged structure which the other river piers do not have. A portion of the old Sellwood Bridge will be shifted onto the river piers to create the temporary bridge. At Pier 20, the length of this shift will be greater than at Piers 18 and 19 to the east, so an extra support structure has been added to shorten the length of the shift. Here's a drill rig on the west side of the Willamette River in late July. This machine is drilling into the ground where a pile will be installed as part of Pier 21. These are the ground anchors north of the west end of the old bridge. The previous slideshow in this series explains how and why ground anchors were installed. Sensors attached to the cables within the ground anchors measure the tension in the cables, which can give an indication of landslide movement in the area. Another component of the landslide stabilization system at the west end of the bridge is a system of shear piles. These are installed in the ground and are made of steel reinforcing bars or rebar and concrete. Here the rebar is being assembled into a cage. Coiled rebar is attached to straight bars using steel wire. The crane is hoisting the rebar cage over to where it will be installed. The rebar is lowered into the ground through a casing. In this photo from November of 2011, you can see that the east end of the old Sellwood Bridge has some very close neighbors, some of which had to be removed in order to make way for the temporary bridge and the new bridge. This photo shows the former location of a condominium which was removed just north of the old bridge. The next condo over will remain unoccupied until the entire project has been completed. Looking down through this area, it's possible to envision the future location of the temporary bridge. Building demolition has been taking place on the south side at the east end of the bridge as well. At the east end of the bridge, on its north side, soldier piles and lagging have been installed to create retaining walls. The steel beams are anchored in the ground and the wooden pieces hold back the soil behind the wall. This has been done to stabilize the area where Pier 17 will be built. Also in this area, to support additional piers for the temporary bridge, 26 micropiles are being installed in the ground. A micropile is made up of lengths of this threaded pipe drilled down into the ground to a depth of 30 to 60 feet. These steel anchor rods are positioned inside the pipe, and the pipe is filled with grout. A concrete footing is placed on top, and the steel rods are then subjected to tension. This shows several installed micropiles prior to tensioning the anchor rods and building the footings. Just like the roots of a tree, there has to be a lot of unseen support below the ground to make a bridge pier stand. This slideshow is the 6th in a series about the construction of the new Sellwood Bridge. For earlier slideshows, please visit www.sitespecificmedia.blogspot.com. For more information on the Sellwood Bridge project in general, please visit www.sellwoodbridge.org.